Hello, this is the explanation for week 5 problem set 5. We are tasked with finding 3 separate integrals. The first one is evaluating sine to the 6th x cosine to the 3rd x dx. I decided to substitute u in for sine of x and du in for cosine x d of x. I then found the trig identity with 1 minus cosine squared x for cosine squared x, and I put that in while factoring out a negative, so I made our sine to the 6th x sine squared x minus 1. I then substituted our u, and then I distributed our u to the 6th in for both of those properties. Then I integrated, giving us u to the 7th over 7 minus u to the 9 over 9, and then simply replacing in u for sine of x, giving us our final answer of sine to the 7th x over 7 minus sine to the 9th x over 9 plus c. Moving on to question number 2, we are tasked with evaluating the integral e to the 1 over x divided by x squared dx. I first started to put our x squared, or our denominator, in terms of factoring those two out. So I found that we have negative integral of e to over 1 over x times negative 1 over x squared. Then after that I could substitute our u in for 1 of x and our du in for negative 1 over x squared. Factoring that in, we get negative integral e to the u du. I then just simply found the integration of e to the u, which leaves us with e to the u, and then factored in our negative, which makes it negative e to the u. After plugging in back our numbers, I get negative e 1 over x plus c. And for question number 3, we were tasked with evaluating e to the 3x sine e to the x dx. I first started with factoring u equals e to the x and du equals d to the x. And similar to our first problem, I found our du dx being of our e to the x, being able to find d of x is equal to e to the negative x du. After plugging that in, I found our u to be u squared, our dv to be sine of u, our du to be 2u, and our v being negative cosine of u. After evaluating that, I found again our u being u, our dv being cosine of u, du being 1, and v being sine of u. And after substituting that in for our cosine u du, I was able to simplify and evaluate our integral with it just left being sine of u to be negative cosine of u, which then turns into positive cosine because our integral is being factored by a negative value. And our final answer we get is negative e 2x cosine e of x plus 2 e to the x sine e to the x plus 2 cosine e to the x plus c. Quite a handful. All right, thank you.